Welcome to the video. In this one we're going to focus on the CAN bus network and the extraction and the analysis of this data. So what is the CAN bus network? CAN stands for Controller Area Network and is a communication protocol that allows devices to exchange data without needing a central computer. So it allows every ECU within the car to communicate between themselves. For example, the wheels can speak to the steering directly. It doesn't need a central computer to run it, and it was developed by Bosch in the 1980s. So here's the two wires that connect everything. So why is this important to us in a forensic investigation? The CAN bus network records critical data about a vehicle before, during and after an incident. This digital evidence can be used to reconstruct events and allows forensic investigators to paint a picture of what has occurred. It's similar to OBD data that we looked at. We get it out the OBD port as well, but it's a lot more in depth, but it also makes it a lot harder to understand. So here's the structure of a raw CAN bus data message. So it starts with an ID tag. This basically tells the other ECU what the message is about, for example, engine RPM or door locks. And it's either 11 or 29 bits, depending on the type of protocol that's being used. That's a normal CAN or an extended CAN. In most vehicles, it's the normal one, the 11-bit one, but for like heavy-duty vehicles, they'd use the 29-bit version. Then we have the data size. This basically, it's just telling the ECU how much data to expect in the next part of the byte. And it's always 4 bits. And then the message content itself, the payload. This is always 8 bytes or less. And then finally we have error checking and confirmation. This is 15 bits plus 1 bit. So here's an example message. We can see the start, we've got an ID. And then a data length code. And then the data itself, so the payload. And the data we're going to look at has been extracted using this CAN Edge tool from CSS Electronics. So this is called a CAN bus data logger. And we can see this is quite a professional piece of equipment. It costs €580. But they provide pre-extracted data sets and open source tools that we can use. So here's a MF4 CAN message that has been decoded into a CSV value, which can be opened in Excel. As you can see, this is quite overwhelming, but we are going to try and break it down. So, as you can see, they've been decoded into human-readable metadata, and the raw hex payload has been unpacked into timestamps, bus channels, etc. And it also includes extended diagnostics that are not part of the raw CAN frame itself. So it's slightly different to the one we just looked at. So here's a breakdown of that CAN message. You can see in the red we've got a timestamp epoch. So epoch is just a way of formatting time, Unix epoch. And in this one it includes microseconds as well. So we could convert this as tools available online to convert these values. Then next in the yellow we have bus channel. This specifies which bus there is. So it actually starts at 0. So this is technically the 10th bus. And in each vehicle, each bus would be designated its own channel. So like, for example, the powertrain's got its own channel. And then we have the ID. In this example, it's likely a powertrain message. We see that's the blue, the 067. And then in the green we have IDE. This is an identifier extension and states what CAN protocol is being used. So it's what we touched on before. So 0 is for the standard 11-bit, and then 1 is for extended 29-bit, which is often used in heavy vehicles or like large building equipment, for example. And then next we have the 8 and 8. This is the data length code and the data length. So the first value is how much data the sender is claiming to send. So here they've sent 8 bytes. And then the data length is how many bytes have actually been received. So this basically tells if the message is whole or not. So if we, for example, if the first value was 8 and the second was 6, we know we're missing 2 bytes of data. And then in the light orange we have the direction of the message. So a 0 indicates that the message has been received, and a 1 would indicate that the message has been transmitted by the ECU. And then the next 3 values in white are extended data length, bitrate switch, and error state indicator. So extended data length states if the message uses CAN flexible data rate, which is just a different way of sending data that's slightly faster. So you've got a 0 here, so that means it's a classic CAN message. And the bitrate switch, this is for if the flexible data rate is being used. So this will be a 1, if the last one was 1 basically. So they know to use a faster bitrate. And then finally in the white we have error state indicator. This basically tells us if the ECU is malfunctioning. So you can see you've got a 0 here, that means it's functioning as normal. And then in the blue we have remote transmission on request. So it sounds complicated, but this basically states whether the payload is included in the message or not. So if that was a 1, we wouldn't have the payload at the end in grey. It would be transmitted remotely in a different packet. And finally we have the actual data payload. Now we're not able to decode this because it is unique to manufacturers and requires OEM documentation. So between brands, for example Volkswagen, this message could be about the power, whereas in a Ford it could be to do with the windows. So it completely varies between brands. And brands often don't release this information to prevent reverse engineering. So in this video we've had a look at CAN messages and seen the format of them. And we've seen that they are hard to analyse without the use of tools. We only looked at 1, but imagine you've got to get through 1,000 of them. And in the next video we'll take a look at a tool which allows us to decode MF4 data and plot it on a graph. Thank you for watching. Bye.